viewers, welcome to add-on. In this question we are asked to minimize the following boolean function, and as we can see the question, the mean terms and don't care terms are given to us, so we need to perform the minimization using k-map. So this is a three variable k-map because there are three variables which are given to us, a, b and c, right? And this sim represents sum of mean terms. Okay, sim represents sum of mean terms, or we can also represent it as summation of m. Okay, and these terms which are given here 0, 1, 6 and 7, this specify the mean terms which are given in the question, and these 3 and 5 are the don't care terms. Okay, so let us construct the k map. So our k map is a three variable k map. So for example, these variables are a, b and c, right? So we are using a to specify the row number in a k map, and we are using b and c to specify the column number in the k map. So now these variables a, b and c, they used to represent only one bit of number. So a can be either 0 or 1, b can be either 0 or 1, and c can be either 0 or 1. So if we are using only a to represent the row number can be either 0 or either 1. So the row number can be either 0 or can be either 1. And now for b or c, if we combine them together, we can use 0 0 0 1 1 0 and 1 1 to represent the column numbers. So we are getting two rows and four columns, 0 0 0 1 1 0 1 1. And these column numbers, they should be written in gray code. These codes are the binary codes, but in the kmap we use only gray code. So for the binary number of 0 0, at first we will get 0, and then we need to sort the adjacent bits together to get the gray code. So we will get 0 0 for the binary 0 0, and now for 0 1, at first the first bit is 0, and now if we sort the next two bits together, we will get 1s or 0, it will be equivalent to 1. Now for 1 0, the first bit is 1, so we will write 1, and if we OR get the adjacent bits, we will get 1s or 0, which will be equivalent to 1 1. And now for 1 1, the first bit is 1, and now if we OR get the adjacent bits, we will get 1s or 0, which will be equivalent to 0. Okay, so our column number will be 0 0 0 1 1 1 1 0, right? 0 0 0 1 1 1 0. And what are the cell numbers? This block, or this particular block, is known as a cell, and this cell number is given by combining the row value and the column value. So for this particular cell, the row value is 0, column value is 0, so we will write 0 0 0, this has a value of 0, so the cell value is 0. Similarly for this cell, it has a value of 0 0 1, so it has a value of 1. Now for next cell, it has a value of 3. Now for the next cell, it has a value of 2, and for this cell it has a value of 4. For this cell it has a value of 5. For this cell it has a value of 6. For this cell it has a value of 7. Now these are the particular cell number. Now the cell numbers 0 1 6 7, these are specified in the mean terms, and the cell number 3 and 5 are specified in the don't care terms. So for the don't care terms, we will write cross in that particular specified cell number, and for mean terms we will write 1 in the specified cell numbers. So for 0 we will write 1, for 1 we will write 1, for 6 we will write 1, for 7 we will write 1, and for 3 and 5 we will write cross, and the cells which are left out we will write 0 here. Okay, now this is our kmf, and we need to do the grouping, and the grouping should be done in the form of 2 to the power n, where n can be either 0 1 2 and it goes on. So we can either make group of 2 to the power 0 1, or 2 2 to the power 2 is 4, 2 to the power 2 to the power 1 equal to 2. So we can make group of 1, group of 2, group of 4, and we need to make the groups including the ones and the don't care terms. Our primary objective is to include the one, but if we include the don't care terms, if that increases the group size, we can also include the don't care terms. Okay, so here in this scenario, this is the k map which is given to us. So let us start the grouping. As I have said, we will make group of 1 2 or 4 ones, and we can also include the don't care terms if that increases our cell size. For example, if we only include the one, it will give us a cell size of, or a group size of 2. but if we include the don't care terms, it gives us a group size of 4. So in that scenario we will also include the don't care terms. So in this scenario you can see we can make groups of this to 1, and we can't include this don't care term. If we include this don't care term, the group size will be 3, which violates this rule, which says that the group size will be in the order of 2 to the power n. So we can't include this don't care term. Okay, so now our next group will be this to 1, and similarly we can't include the don't care term because then the group size will be 3, which violates our 2 to the power n group size rule. So these are the true groups, these are the two groups which we are founding out from the given k map. So we will write the boolean expression for these two groups. Now if we notice these two groups, the value of a, let us specify the a is the row value and b c is the column value. So in this scenario the value of a is fixed at 0, but the value of b c, if we look at this, the value of b is fixed at 0, the value of c is changing. So we are only including those variables whose values are fixed. So in this scenario for this group we will be including only a and b. We will discard c because the value of c is changing from 0 to 1. And if the value of a particular variable is 0, we will represent it as that variable with a bar above his head. So if v is a variable, if the value of v is 0, it will be represented by v bar, and if that value is 1, we will represent it by simple v. So in this scenario, the value of a is 0, the value of b is 0, so we will represent it by a bar b bar. And for this group, the value of a is fixed at 1 and the value of b is fixed at 1. The value of c is changing from 1 to 0, so we will discard that value. So we will be getting the value of ab. Okay. So this is our minimized boolean function from the KMF which is given to us, which is a bar b bar plus ab. Thank you.